Thank you. So I guess you can hear me. Obviously, it's kind of a difficult time right after lunch, but I hope I'll keep your interest. So yes, as Dimitris mentioned, I'm Lazaros. I'm a lead cloud engineer for Chubb. It's very nice being here around all these nice and skillful people. So today I'm going to give you a short presentation in regards to cloud infrastructure best practices in a multinational corporate, and to some extent making it possible to support applications at scale. And by that I mean supporting hundreds, if not thousands of applications based on our infrastructure if we implement it in an abstract way. Just give it a moment. Okay. So regarding our agenda, long story short, I'll tell you a couple of things on how we can move from well-defined infrastructure to abstract infrastructure components. I will let you know what that means from this kind of perspective and mindset. And we'll finish with a couple of aspects in regards to network security and FinOps. And why all these are important? The first points are important in order to, as mentioned before, be able to support hundreds, if not thousands of applications at scale. And obviously, the last 2 points, because security is always a hot topic, and FinOps, meaning cloud savings and cost efficiency, once again, in our world in the latest days, it's quite a big deal. So I tried to keep it quite short in order to not distract you with too many words. So what do we mean usually by well-defined infrastructure? In most projects, in most, let's say, startups or even mid-size companies, when we're working in just a few applications or a specific product, and so on, we usually have something very well defined, a complete architecture of what we're going to build. We know upfront the components that are going to be our infrastructure and cloud services, if you like. So we know upfront what we need to build in terms of our configuration, either infrastructure as code or configuration as code. And this kind of make our life easier, let's say, because we know upfront what we target. This might not be the case when we are trying to implement our infrastructure in such an abstract way. And obviously, if anyone is coming from a software engineering background, can understand the distinction, for example, of having a well-defined class rather than having an abstract class or an interface and stuff like that. Can we do that in infrastructure? Yes, we possibly can. What advantage this might give to us? Imagine that we're having a big company, probably working with outsourcing clients and vendors and stuff like that. And maybe there is a need that we need to build our infrastructure and serve, let's say, our infrastructure in such a way that we give the agility to the development teams to actually design what they want without us, from the infrastructure side, knowing upfront what their needs are going to be. And let me move forward and let you provide you actually on how this can be possible. And let me start with a paradigm. So for example, if we're working on a software project, and let's take it, for example, a front-end project, there might be a possibility to design and implement a UI library in order to make our components reusable. So for example, create buttons, checkboxes, whatever might be in regards to our UI library, and pretty much leave our users, our software engineers, consume these in an ad hoc manner based on their needs. Can we make our infrastructure work like that? Yes, possibly we can. So, how can this be done? Let's start with a buzzword, let's say, and by modularized configuration, whoever has worked with infrastructure as code, for example, Terraform, knows about modules and how these can be implemented and consumed. But I won't go deep down in technical aspects because there might be people not proficient in these technologies. So high level speaking, we can pretty much do the same we can do with a UI library, for example, in an infrastructure way. How this can happen? So, for example, we could possibly implement specific configuration for what services we might need. What is a service from an infrastructure perspective? So, for example, some compute services, virtual machines, or some platform as a service component like app services, if we're speaking about Azure, or the equivalents, obviously, in AWS or GCP. Then we might have some kind of storage, some kind of vault to store our secrets, databases. So whatever the architecture and the needs might be, we can pretty much split in small reusable components, implement our configuration like that, and then obviously provide our development teams with the specific documentation and pipelines in order to ad hoc, based on their needs, based on their architecture, provision what resources they might need in order to make their application work. So pretty much that's the reason behind all this, and it's let's say it's not a specific implementation, but let's think of it like a design pattern, let's say. So it's a kind of how we structure our configuration in order to be easily consumable in a reusable way. Sorry about that. So, what are some of the challenges we might face if we design our infrastructure as such? Obviously, one big hot aspect is security, and especially network security. So, providing our infrastructure in such an ad hoc and abstract way puts us in a position that we need to predict and design the whole thing in such a way that anything will be transparently put behind some virtual networks, providing some kind of security and so on and so forth, because giving the ability to the application teams to provision their infrastructure in an ad hoc manner means that obviously we need to take care upfront where this infrastructure is going. Meaning which virtual networks and how we make it so that nothing is exposed and we prevent having a big attack surface, and so on and so forth. And as most of you know, I guess, we can have quite a few services like load balancers, firewalls, obviously network security rules, and so on and so forth. And this should be pretty much well defined from us, from the infrastructure team, before setting up the whole process of abstractly provisioning the infrastructure. And one well-known, at least for people that are working on infrastructure, one well-known architecture topology is the hub and spoke topology, meaning that we can have a resource group, let's say a set of resources in what we call a hub, which is pretty much a component, a wrapper, to put it in these words, that can host shared services. And then we can obviously have our spokes, which can be multiple spokes, which can host pretty much separated services, and all of these can intercommunicate with each other. What advantage does that topology provide to us? It gives us the advantage to have shared services, let's say one service for all our spokes. And as a spoke, imagine that we might have multiple products, or let's say multiple microservices of the same product. So for example, instead of having 3 firewalls, we can have one hosted in our hub. We can have one bastion to connect to each spoke rather than having 3 of them. And to take it to the last point of my presentation, another advantage that such kind of topology gives us is to have some kind of cost efficiency on our infrastructure. So this won't take much long, and it's actually the last couple of slides of my presentation. So for any of you that never heard the FinOps term before, it's based on financial operations, and pretty much the target is to have cost efficiency on our, especially on our cloud infrastructure. The main aspects of FinOps is its phases, and I will elaborate a bit on what that is, and the FinOps maturity model, which defines in which step of our maturity circle we might be as a company, obviously. So in terms of phases, it's defined as the inform, optimize, and operate phase. The first one, inform, is pretty much getting all the data we might need in order to have some kind of dashboards and have visibility of what we spent on the cloud, and also be in a position that we can allocate our costs to specific teams and so on and so forth. This makes even more sense if we're working on a large company, having multiple teams using the cloud and provisioning resources in the cloud that cannot be centrally managed, let's say. So it's very different having one product in one company of 40 people, for example, rather than having thousands of products, thousands of applications split in multiple teams in a very large-scale company. Then optimize phase has to do with the fact of what we're doing with the data we have and how we can implement, identify actually the opportunities to provide cost savings, for example, having reserved instances or having better utilization of our resources. Imagine having a Kubernetes cluster that is being utilized on 40%. Why not having a lower SKU and have it utilized in a much better way, like 80 or 90%? And then obviously the operate phase has to do with actually implementing the automation, let's say, in order to take advantage of whatever we set during the first phases and implement the mechanisms to do it in an automated way. So for example, having auto-scaling mechanisms and stuff like that. And obviously these phases can run in a loop continuously in order for us to be in a much better position and to optimize the process. And having those run in a loop, obviously in the long term, will move a company between the stages of the FinOps maturity model. Obviously, when we start from the crawl stage, which means that we don't have pretty much any identification of and visibility of our costs. We don't have the mechanisms to have this automatically be optimized and so on and so forth. And gradually we move towards the rest of the stages from walk to run based on how we mature our processes in order to make this even better and maybe finding anomalies, taking action in an automated way and so on and so forth. I'll keep it in a such high level at this point, but I guess I give you at least a couple of items to think of and either ask me afterwards or have a look yourselves. So this was pretty much it. And to sum up, what we listened for today was how we can work on abstracting our infrastructure components and make them reusable, which makes sense as we go from smaller scale, from a small number of applications going towards a very huge number of applications and not knowing upfront what our dev teams are going to need from us as an infrastructure team. Then moving to a couple of aspects in regards to network security, finishing with some FinOps practices. And that's it from me. I hope it was interesting. Thank you very much.